One of the key parts of this video and the other video in this section is that they solve the same problems. The goal here is that for you to see the difference between the two algorithms, but also understand why one can be more effective than the other in certain situations. So this video will be covering the standard algorithm for multiplying multi-digit numbers. If this one doesn't make sense to you, there is an available algorithm on partial products, and I do highly recommend watching both of those videos to see how they compare. So when we're looking at the standard algorithm, it's actually the same process as partial products, except we take the steps and we do them all in the same vertical line. So as I look for this problem, just like partial products, I'm going to be multiplying 8 times 4 to get 32. Now, in partial products, I would write that all down here at once. But instead, what I do is I do 8 times 4, which is all in the ones column, and I take that 32, and I take my 2 ones, and I draw it there, and I take my 3 tens, and I move it up to the top. Then my next step, just like partial products, is going to be 3 tens times 8 ones, or 30 times 8, which is 240. But I only care about the 40 for now. I take the 24 tens and I add my 3 tens and I get 27 tens. So my 7 goes here in the tens column. If there was a hundreds place, it would go up here, but it's not. Therefore, I write it down here at the bottom. So I have 34 times 8 gives me an answer of 272. When we move on to tougher problems like 657 times 4, the process is going to stay generally the same. Once again, I start as far to the right as I can. I look at my 4 ones and my 7 ones and I multiply them together. 4 times 7 gives me 28. However, instead of writing that all as one step, I take only my 8 ones and I draw it here, and I put my 2 tens and I bring it up to the next column. Now I have 5 tens times 4 ones, which is 20 tens. But once again, I only care about the tens number, so that would be 0, but I'm going to add 22 tens. Therefore, the 2 goes there. The other 2 goes up into the hundreds column. So then I have 600 times 4, which is 24 hundreds, but then I add in 2 more, which gives me 26 hundreds. Now, as we work through this problem, I care more about the fact that you understand the terminology rather than use the terminology in every single circumstance. So if you would say, for example, 6 times 4, I would say that is incorrect by definition. But if you said 600s times 4 gave me 2400s, I think that's absolutely excellent. You don't always have to say 600 times 4. That's just more comfortable for me, but you have to do what's best for you. So as we move to the next step of the algorithm, these do get a little bit more difficult, but not infinitely. So once again, I want to start with my 3, and I do 3 times 5, which gives me 15. I put the 5 into the ones place, and the 10 goes above the 4, just like we did before. Now I'm still going to do 3 times 4, but this is now 4 tens, which gives me 12 tens. I add one more to get 13 tens. There's nowhere to move that hundreds place, so I just simply have my 13 tens go here. Now this is where some people will put an X over this number to remind them that they're done with the 3. I'm fine with that, but I do not like putting the X down here at the bottom because the X represents a 0, and I'm going to show you why it represents a 0. So for this number here, this is 20. 20 times 5 is 100. So the 100 goes above here, which is one of the issues with this algorithm. You have to be very careful about that. But you end up getting 0 in the tens place. Well, if there's 0 in the tens place, there's also a 0 in the ones place. So instead of putting an X here, I immediately, before I start this problem, put a 0 here. Now I do my 2 tens times 5, which gives me 10 tens. So the 0 goes here, and 1 goes up to the hundreds place. Now I do 20 times 40, which gives me 8 hundreds, but I have to remember to add the extra 100, so I end up getting 900 for that bottom column. And now I add what I have. So this is 0 and then goes into the thousands place. So 45 times 23 is 1,035. Now as we move down to what we would call a level 3 problem in 6th grade, you have 434 times 87. If you watch the partial products video, our work actually took up this entire page. It was pretty lasting. Now, when we work through it here with the more standard algorithm, we will actually have plenty of room and plenty of space. One of the big benefits of this algorithm. So, in the ones place, I have 4 times 7, which gives me 28. The 8 goes in the ones place. The 2 tens go up above the tens place. So then I do 3 or 30. 3 tens times 7 gives me 21 tens plus our extra 2, which is 23 tens. And I'm going to move 200 up above this column. So then I have 400 times 7, which is 28 hundreds, plus our extra 3 gives us 30 hundreds, or 3,000. Now that we're done with our ones place, I'm going to mark that off. I go down here and I'm going to add a 0 because I'm now working in the tens place, which means that no matter what happens, my ones place will have to have a 0, so I can insert the 0 there. So I have 8 tens times 4, which is 32 tens. So my 2 goes here for 2 tens, and then I bring my 3 hundreds up. I do 80 times 30, which is 24 hundreds, plus my 3 from before, sorry. So 24 plus 3 is 27 hundreds. So that goes here. And I bring that up. And now I do 4 times 8, which is now 4 hundreds, times 8 tens, which is where this is where it gets really tricky, which is 32 thousands. But I have to add in the extra 2 thousands, so it's 34 thousands. I take what I did there and I add it all together. So 434 times 87 is 37,758. Now, I want to rework this problem a little bit just to show you some of the differences in the ways that some people will work out the terms and where I want you to be very careful. Okay? Now, the first row I think we're probably fine with. That ends up getting to this place here. Okay? This is just like all of our other problems. We end up getting 3,038. Now, our terms get very difficult down here on the bottom. So we have 8 tens times 4 ones, which gives us 32 tens. What I like to do is I like to identify the column that I'm currently in, and you say the number of that column. That's what you have to be working on. So when I get a little bit lost with these numbers, I look down and remember, okay, I'm here. So it's 32 tens. So my 2 goes here. And then this is where I have a little bit of an issue with the algorithm, though, because you're moving 300s up, but you move it above the tens place. So you have to be very cautious with that. So now I'm working in the hundreds place. And so I have 24 hundreds. I then add here, and I get 27 hundreds, remembering that we're right there. So I bring up my extra 2. But once again, I move the thousands into the hundreds place. You have to be very careful with your terminology. So then I do my 400 times my 8, which gives me 32. Now I'm working in the thousands place. So I have 32 thousandths, but my extra 4. So it ends up being 34 thousandths, or 3,000, or 3 ten thousandths, 4 thousandths. And I think for most people, when you get above the hundreds place is where it gets a little bit trickier to kind of keep your terminology correctly. I am always hoping that you get the first 3 columns correct every time. But once you get up into the thousands place, I think it's okay to be a little bit more careful and have to think about it a little bit more. So just remember, once you get above those numbers, always look at the place value that you're currently working on to help you know the name.